Working with two-step equations. The first step with a two-step equation is you want to undo any addition or subtraction. The second step is you're going to undo the multiplication or division. Now, multiplication or division, it will be attached to the variable. The addition or subtraction, you will see a plus or a minus sign. But with multiplication and division, you don't see multiplication and division signs. So in this example here, notice that I have a variable over top of a number. Well, that is attached to the variable, so I'm not going to do that in the first step. My first step here is I'm going to deal with the plus, and I'm going to do the inverse or undo plus by subtracting. So I'm going to subtract 2, and I need to subtract 2 from both sides of the equal sign. So I'm going to be left here with that x over 3 equals 6. Now, when you have a variable on top of a number, that line that it's over represents division in an equation. So when you see a variable over top of a number, we have division. And in order to remove the division, we have to do the inverse to division, which is multiplication. So to solve for x, or to isolate x on one side of the equal sign, I'm going to need to multiply both sides by 3. That will remove that division there, and I will have x by itself. And then I'm going to need to multiply the 6 times 3 to get my answer, so I end up with x equal 18. So this next equation, you're going to see it's a two-step equation, but I have a fraction attached to the variable. Now, we don't want to work with what's attached to the variable first. We always want to do the opposite of the addition or subtraction first. So because I have subtraction here, I need to undo subtraction by adding 9 to both sides. So what's going to be left is that fraction that is attached to the variable, 5/7 x, and it's going to equal a negative 20. And that negative 20 is coming from the fact that we have different signs, and you have to subtract and keep the sign of the higher number. So now I need to isolate the variable, which means I need to remove that 7 over 5. Well, to remove that 7 over 5, if I multiply by its reciprocal, I'll end up getting it equal to 1, and then I'll have the variable by itself. So remember, reciprocals are simply the flip of the fraction. So I will take the denominator, make it the numerator, and the numerator becomes the denominator. And this will be the reciprocal of the fraction that is attached to the variable. And when I multiply the reciprocals together, I will end up getting 1, or it will cancel out. Now keep in mind, whatever you do to one side of the equal sign, you have to do to the other. So because I have an integer, I'm putting that integer over 1, and then I'm going to multiply it to that fraction. You always want to multiply fraction to fraction. So now I'm going to simplify, and when I simplify, that fraction that is attached to the variable will be removed. Don't lose your negative sign, so you end up simplifying here. 5 goes into 5 once, goes into 24 times, and now I can multiply across. So I have a negative 4 times 7 will give me a negative 28. You don't want to leave your answer over 1 because it simplifies, and it simplifies to an integer. Pause and try. So we're going to add 1 to both sides. Then you have that division, so you're going to multiply both sides by 7, and you're going to end up with your solution, x equals a negative 28. Pause and try. So you're going to add 6 to both sides, and then you're going to deal with that fraction by multiplying both sides by its reciprocal. Put that integer over 1 and multiply by simplifying and multiplying across. So in this case, you should have ended up with x equal 20. So this next example, we're going to work with writing equations from words. So I'm going to do the reverse. I have an equation here, and I'm going to write it in different ways that you would see it in a word problem. So the most direct route is to first start with the variable. When I have a variable, it's an unknown. So in a word problem, it might be represented by the words a number. So a number represents an unknown number, and I would label it with a variable, and in this case, I have y. Now when you see plus 9, I could actually write those words, plus 9 equals 15. So this is the direct sentence that would equal the equation. So if you're given this sentence, you would be able to write the equation. Other ways that you may see this written in words would be a number increased by 9. So if you see increased by 9 and you're writing an equation for the words, you would use addition. And you would see is 15. A commonly used word for equals is the word is. Another way you might see this written in words is 9 added to a number. So I'm adding 9 to a number is 15. Next, you might see the word sum. So if you see the word sum, it means we're adding things together. So the sum of a number and 9, so that's my variable plus 9, is or results in 15. Next one, you might see 9 more than, and that word than is important. That placement of than means that it's coming after whatever is written next. So 9 more than a number means that I'm going to have that variable plus 9 is 15. So subtraction has different words that would be used in a verbal problem. So a direct route here would be a number minus 4 equals 20. So a number minus 4 equals 20. That is a direct way of writing this equation. But we might see it written in other ways. Like a number decreased by 4. So that means I'm subtracting 4 from a variable is 20. Another way you might see is subtract it from. And that from is very important because when you see from, it means that it's going to come after whatever is next in the sentence. For subtracted from a number means that the variable is coming first and then you're going to have subtraction. So it's important because with subtraction, if you don't write the equation correctly, you'll end up with an incorrect answer. Is 20. The difference means subtraction, so the difference of a number and 4 results in 20 is another way you might see this written. And then you have 4 less than, and that than is also very important. It means it's going to come after what is written next, a number, so it's 4 less than a number means that that minus is coming after the variable. Is 20. So it's important with this certain word and how you're going to write your equation with subtraction. And this next example is an example of a two-step equation. So I'm going to write this directly how I would do it in words. So if I saw 2x, I know that 2 is being multiplied to x, so I could write it as 2 times a number, and then minus 29 equals 7. So these are the words that would be directly written based on what I see. But I could also see it like this. Twice a number decreased by 9 is 7. So you see here that twice means I'm multiplying 2 to a variable. Decreased is minus. 29 subtracted from, so here's that from, that means that that subtraction is going to come after whatever comes next in the words. So I have 2 times a number is 7. And then you could also see the difference. That word, the difference, means I'm subtracting. So the difference of twice a number and 9 results in 7.